Our last lesson of this unit, which is, there we go, the nature of the roots. The nature of the roots. So this is technically, I've written down as part 2 of our previous lesson because the 2 lessons are really connected. Last lesson, what we did was we looked at, what's called a quadratic formula. It's a formula that can be used to find the roots of a quadratic equation, but it kind of assumes that those roots exist, right? So if those roots exist, you can use this quadratic formula to find what those values of the roots are. So rather than focusing on the values of the roots, today we're going to be looking at what are called the nature of the roots. And so I've just got the quadratic formula tucked up there in the top right-hand corner. You don't have to write it down again. I would just write down the title, the nature of the roots. And then what we're going to do is we're going to look at a couple of functions and sort of think about them. All right? So the instruction here says, consider this particular function. And we want to look at it and kind of analyze the parts of the function and see if we can sort of visualize or at least use our brains to think about, can we tell for sure how many roots or x-intercepts there are for this particular function, this one here. So over the last few days, we've kind of hopefully recognized that our answer is either going to be 0, 1, or 2. So when we look at this function, can we tell for sure whether there is 0, 1, or 2? Thumbs up, I can absolutely tell that there are. Thumbs down, I can absolutely tell that there aren't. And then thumb sideways, I have no idea what you're talking about. Or, I can't tell. And it's okay to have it sideways that you can't tell. Okay, so either thumbs are up, thumbs are sideways, or thumbs are down. The first one, the one that's got the little square around it. Okay, excellent. Sorry, I couldn't quite move it there. There we go. So y is equal to negative 1/3 x minus 5 squared plus 3. Okay, so thumbs up. I see a fair bit. I see some thumbs. I see one thumb down. Sabrina, can I pick on you? No? Oh, no, now you've shifted it from down to sideways. Okay, well, that's fine. That's fair. So does anybody still have their thumb down? Okay, so thumbs are either sideways or up, right? And sideways, fair enough, because when we look at this, we maybe need to kind of process what is it that's making the rest of the people put their thumbs up. Right, which means that there are x-intercepts, and we know how many there are, right? Because we said thumbs down if there weren't any, and then thumb sideways if you're not sure. So remember that when we look at a function, right, we don't want to rely on our calculator, but if we take the basic function, y equals x squared, right? The center or the vertex is at the origin, right? Because there's no p value, there's no q value, and our a is positive, so it's opening up. And then you simply process, well, what's going on here? So the negative says it opens down. The 1/3 really doesn't affect it. Then it's moving 5 to the right, and then 3 up. Well, then because that vertex, so basically we sort of take this, and then because it moves up, it's going to move that vertex point above the x-axis, and then it's opening down so that it will cross the x-axis. So the answer is yes. How many roots there are? And there are 2. Okay, absolutely we can tell with that one. So the question is, can we always tell? So can we tell with this one? Positive 1/3 x plus 7 all squared. Yes, thumbs up. I know how many there are. I guess that would be 1 or 2. And then thumbs down, there aren't any. Or thumb sideways, I'm still not quite sure. But now having walked through one, hopefully we don't have as many sideways thumbs. I was going to say sideways thumbs, but... Okay, so thumbs up, there are, and it's either 1 or 2. Thumbs down, I know that there aren't any. Okay, so that's kind of a confident thing. And then thumb sideways, I'm not sure. right? And then the only reason your thumb should be sideways, think back through it, right? Just like we did with this first one. Think about the basic function. Think about the basic function. Y equals x squared. All right, first things first. Do we have a negative? No. Okay, so it does not flip it, right, in terms of the a value. The 1/3, it's not going to change the vertex. So the a value really, the numerical value doesn't matter. It's only if it's positive or negative is that really going to affect things. So it's still opening up. The 7 inside there says move it 7 units to the left. And then there's nothing after that, is there? Right? So it's not moving it up or down. In other words, it's not moving it off of the x-axis. So there is gotta remember where it starts. Remember that it starts on the origin. So that there is, that's okay to be confident but wrong, but now you're hopefully going to be confident and right. Right? Because remember where it starts. It starts at 0, 0, so it is on an x-intercept. So there is a solution, it's just that the solution is 0. So by moving it just left and right, there is still an x-intercept, but there is only one of them.
Because it's the vertex x-intercept, right?
In this particular case, yes.
Okay.
And if you were to look at this in factored form, in fact, this one is in factored form. The reason it's in factored form is because there's nothing tagged on at the end. Right? So we've got the a value of 1/3, and we've got two factors. They just happen to be identical. And so this shows that the x-intercept, well, this one actually gives us, the answer too. There is going to be one x-intercept, and it tells us that the x-intercept is going to be -7. This tells us that there are two x-intercepts, but now we need to find them. Right? This one doesn't specifically tell us where they are. We have to find them, and we could find them by graphing, perhaps, by completing the square, perhaps, right? Or we would need to, in order to use the quadratic formula with this one, though, we'd actually need to expand it out, because remember, your quadratic formula only works when your quadratics are in this form. All right, now, what about this last one here? Y is equal to x minus 5, all squared, plus 2. Thumbs up. I know that it has x-intercepts, and that's either 1 or 2. Thumbs sideways, not sure. Thumbs down, I know there aren't any. And our goal here is to move the thumb off of the sideways mark, right? Just by thinking through. Visualize what happens. Think of the transformations. So your options, as again, is thumbs up. I know that there are x-intercepts, and there is going to be either one of them or two of them. Thumbs sideways, I'm not sure. And then thumbs down, I know that there aren't any. Right. So again, think through. All right. Think through what happens here. All right. So we walk through, and again, the first thing we look for is the direction of opening. From our basic function, is this opening up or down? Right? The answer is it still opens up. Okay, which means its starting is still kind of like this. What happens now to this parabola piece? Question is, does it move up off of it, or does it move down below it? The answer is, well, first of all, the -5 in there means it's going to move over to the right. I just want this. It's going to move to the right 5 units. And then this +2 means that it moves up. So the answer is, thumbs should be down, right? I know that there are no x-intercepts for this. Now, this is one of the particular outcomes that you should recognize, that when it's in this form, you should be able to tell how many intercepts there are. Right? You can tell, and this is the hardest one, you can tell that there is 0. You can tell that there is 1. And you can tell when there are 2. Okay? From this form, it's clear. You just have to process it. Okay? There's going to be 1, this is the easiest one to see, if Q is 0. If Q is 0, then that means there's no movement up or down. Then there's automatically 1. It can move left and right. It can flip up or down. That doesn't matter. And the stretch doesn't matter either. There will be 0 if A is positive and C is positive, or if A is negative, oh sorry, I should not C, Q. Let's get the right letters in there. If A is positive and Q is positive, that means it opens up and moves up. And that means they're going to be 0. Or if A is negative and Q is negative, then that means it opens down and then moves down. Now we can shorten this, and this is going to be kind of a little mathematical sort of thing. If A is positive and Q is positive, what is A times Q? And if A is negative and Q is negative, what is A times Q? Still positive. So we can shorten that to say if AQ is positive, then there will be no x-intercepts. You can shorten that. I hope we didn't. I hope I turned that off. Well, somebody watch that tonight, or actually maybe one of the ones that isn't here tonight will watch that and let me know if we made it. All right. So how do we know then if there are going to be 2? Well, basically it's going to be sort of the opposite of the 0. In other words, if A times Q is negative, then we will have 2. So what that basically means, if your A is positive and Q is negative, that means it opens up, but it's been moved down, and that means you're going to get 2 x-intercepts. Or if A is negative and Q is positive, that means it opens down, but then it's been raised up so that the vertex moves up, and then you've got 2 x-intercepts. So the green are probably just, they're shorter ways to sort of recognize that. Okay. That's only if it's in this particular form. So in vertex form, you can always tell. And I think the easiest thing to do is just kind of visualize it, right? Take your y equals x squared, does it flip, and then how does it move? Okay, so that kind of describes a little bit about the nature of the roots. We don't know what they are. At least most of the time we don't know what they are, especially when there's 2. But from that particular form, from vertex form, you can tell how many x-intercepts there are going to be, okay, when it's in that form. Well, now the question is, well, what if it's in a different form? Well, if it's in factored form, that's because that's another form, then obviously you can tell what the x-intercepts are because they're right there in the factors. So the tricky part now comes in, what if they are in standard form? Y equals 2x squared plus 5x minus 9. Now, can we tell for sure how many roots that function has? Thumbs up, it's 1 or 2. Thumb sideways, not sure. Thumbs down, there aren't any. And oh, just a minute. No. Yeah, we'll do that. Thumbs up, there are 1 or 2. Thumb sideways, we're not sure. Thumbs down, there aren't any. Okay, and we're simply really wanting to answer the question, can we tell for sure? Okay, so the thumb sideways basically means I'm not sure, so we want to be able to know for sure, right? That's the goal here, so that we can know for sure what's going on here. So, anybody got their thumb up? Kevin, can I call on you? Yeah. Okay, why are you sure that there are? Shh. Which one's positive and which one's negative? What does that mean? Yeah? So you were paying attention the last couple of days. Yes, right? If the A value is positive and the C value is negative, that means the y-intercept is down below. And if the A value is positive, it opens up. It must come up and cross. Excellent. Okay, so we should have thumbs up here. Can we tell for sure how many there are for this one? The answer is yes, since we can see that A and C are opposite signs. Right? Guaranteed. Okay? Now, let's come down to this one. X squared plus 6x plus 8. Thumbs up. Thumbs sideways. Thumbs down. Thumbs up. I know for sure how many there are, and it's 1 or 2. Thumbs sideways. I'm not sure. Thumbs down. I know that there aren't any. Right? Thumbs up, 1 or 2. Thumbs sideways, not sure. Thumbs down, I know that there aren't any. Now this one's a little trickier because A and C are both positive. So if your thumb is up, you're saying, yes, I know for sure that there are, and here's how many there are. Julian, you got your thumb up. You've been holding it up like all day here. Well, not all day. There's one. How can you tell? Okay, so that means you don't know for sure if you're guessing. All right? I want an answer from someone who is saying, thumbs up, I know for sure how many there are. Okay? And then, so nobody else had their thumb up. Okay? Somebody have their thumb down. Anybody have their thumb down? And are you willing to share with us, why you had your thumb down, that you know for sure that there aren't any? Yeah. You did? Sure? You did it right? Are you sure you did? And what happened? Yes, A and C are both positive, but that's, if you complete this, if you complete the square, you should have it into this form. Yeah. And then we want to talk about A and Q. Yeah. Oh, and A and Q were both positive. Yeah. You sure?
Okay. Go back.
They're both negative? Are you sure? Because the A value right there looks positive. So here's the question. Is it possible to complete the square to check it? And the answer is yes, absolutely. Now the only thing is, did you use your pen or pencil there? Okay, so if you use your pen or pencil, I think you'll find that A and Q are actually opposites. Right? But anybody else with their thumb up that said no, for sure there aren't any? Okay, or sorry, yeah, thumbs down. That's what it was. Shayla, you had your thumb down. Okay, so can I just repeat exactly what you said? You said they're both positive, so we don't know. So that means your thumb should be sideways rather than down, right? Because thumb up says, I know for sure that there's 1 or 2, right? And I know which one it is. I know it's either 1 or 2 or not. Thumb sideways means I'm not sure. And then thumbs down means I know for sure that there aren't any. Okay? So, most of you now, I'm guessing, then have your thumb sideways. Do you have your thumb sideways yet? Or at least did you have it raised from the down? Or is it still down? Don't complete the square. Now, you can. Sure you can. But there's a process there, right? Like the completing the square process takes a bit. How else could you tell if these will have x-intercepts? What's something that we could do to find those x-intercepts? We did a whole unit on it, actually. Yeah. Does this factor? Oh, does it? Really? Well, then if it does, guess what? Now we can put our thumbs up, because if it factors, then we know for sure how many factors there will be and whether they're different or not. Okay, so this particular one, a little sneaky one there, this one does, and really the easy thing to do is by factoring, we can tell. So even though both A and C were positive, we still had to kind of think one step further. And we could either complete the square, or we can try and factor it. Okay, how about this second one? X squared plus 8x plus 16. Thumbs up. Yes, there are factors, x-intercepts, and the answer is either 1 or 2. Thumbs sideways, I'm not sure. Thumbs down, I know for sure that there aren't. Okay, so I see some thumbs up. I don't see any thumbs sideways at all or down, and I see a lot of hands just passive. So let's get a thumb, in one direction or another. What's that? Oh, okay. All right, so first of all, A and C are both positive. So what do we do? Did you factor it?
Yes.
Okay, and does it factor?
Yes.
Okay, so now, since it factors, put up how many fingers for how many roots there are. There can't be 10. Right? Since it factors, the answer is there's either only going to be 1 or there's going to be 2.
Sir, but, yeah, it's one.
Right? And the answer is it comes down to 1. Because when you factor this one actually factors into, and if you complete the square on this, it actually completes the square to be this. Right? X plus 4 squared. In other words, there are 2 factors, but they're identical. Right? So we would say that there's really kind of just one factor or one root. All right, what about this last one here? X, or not last one, third one here. Y equals x squared minus 2x plus 8. Thumbs up, absolutely. And they're either 1 or 2. Thumbs sideways or thumbs down. I know for sure there aren't any. The last one there on the right-hand side, y equals x squared minus 2x plus 8. Thumbs up, thumbs sideways, thumbs down. Well, you're processing. Okay, so in other words, if you're processing, the first thing you're doing is you're going A and C are the same. Okay, next step is, can they factor, or can I factor this? Does this factor? Okay, are there 2 numbers that multiply to make positive 8 that add to make negative 2? No. Okay, now does that automatically mean that there aren't x-intercepts? Right? No. Okay. So hopefully we're learning something, right? That doesn't necessarily mean that. So now, the question is still, well, where's the thumb? Just because it doesn't factor, doesn't tell us anything yet. Is there a way that we can either move that thumb up, or that we could move that thumb down, rather than just leaving it sideways? Maybe it's okay at this point to leave it sideways. Complete the square. Okay, so you could complete the square on this to see what's going to happen, because then once you complete the square, you'll get it back into this form, right? Now, how many of you like completing the square? Okay, that's fair, right? It's not, trust me, it's not my favorite activity either, but it's an option. Okay, the question is it the best option? So at this point, now, did anybody complete the square on this one? Working on it? Okay, don't work on it. Yes, completing the square, we'll put it into this form, and then you can always tell in this form. But the question is there a faster way that we can tell? Well, that's hopefully what we're going to come up with. So this one, yeah, does not factor, but is inconclusive as to what's going to happen here. All right, what about this one? X squared plus 6x plus 7. Thumbs up, 1 or 2. Thumbs sideways, not sure. Thumbs down. And without completing the square. Because the answer to our problem is, yeah, we could complete the square on absolutely anything to tell. But just quickly, can we tell? So, thumb up, thumb sideways, thumb. Oh yeah, different question.
On a test,
Yes.
would it ask you to quickly look?
It may ask you, can you tell,
Okay.
and explain. Like it'll ask you to explain how you know
But you can still like,
without graphing.
you can still do it and never find out.
But your explanation needs to be legitimate.
Yeah, but you could. Yeah, hey, multiple choice. Okay, I know a shortcut.
It's okay, I know the shortcut. Okay, thumbs up, thumbs sideways, or thumbs down on x squared plus 6x plus 7. Okay, Christine, you had your thumb up. Can I pick on you? How do you know for sure? Yeah. Okay, so all three terms are positive. Yeah. All right. So since A and C are positive, not sure. So does it factor? Okay, but does it factor? Can it factor? Can you think of, well, are there two numbers that will multiply to make positive 7 that will add to make positive 6? Okay, so in other words, it doesn't factor over the integers, right? So then the next question is there another way that we could tell whether it, will produce roots? The answer is, well, apart from completing the square, there's nothing else here that indicates that it does. Okay, unless we go through the process of completing the square. So if your thumb is sideways, awesome, right? Because at this point, don't know. What about this last one? X squared minus 6x plus 7. Thumbs up, thumb sideways, thumbs down. 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2. Okay. Again, see the initial problem is if A and C are the same, that's where it causes a little bit of And then if we can't think of two numbers to factor, how can we tell? Now, put that calculator down. Here's what I want you to do for these last three that we were working on. This one, and this one. What I'd like you to do is I'd like you to set up the quadratic formula for each of them. Don't let Siri set it up. Just set it up, but don't simplify. Okay? In other words, what I would like you to do is simplify underneath the radical and simplify the denominator, but don't go beyond that. Okay? Do those for each of these three. And then after you kind of have done that particular set of steps for each of those three, then we'll graph it and look. Okay, so I'll kind of start you off. So this is what we want it to look like. Right. The nice thing is all of these functions are in ax squared plus bx plus c form. So I'll do this middle one. This is what we want you to show, and I want you to write this down in your notes. So x is equal to the negative of b, so that's negative 6, plus and minus square root of, now b squared minus 4 times a times c. And since a is 1, whether you write it in there or not, doesn't matter, all over to a. And now, basically, just work at what's inside the radical piece. 6 squared, and then minus 4 times 7. So what's 4 times 7? And now what's 36 minus 28? 8. Okay? So get to that stage for the other two. And keep them kind of all in the same line here. And then down below, what we'll do is we'll just made myself some more room there. Look at that. And then what we'll do is we'll kind of just quickly sketch, well, what does each look like? Okay. Okay. So in there, sort of not quite fully simplified, but just after you evaluate the radicand, for the first one, what's the number underneath there? Negative 128? I think just 28, but it is negative, right? Okay, so negative 28. The second one we already had there was a positive 8. And the last one here, also a positive 8. Okay, now underneath here, we're just going to quickly sort of tag in here. Well, what do these functions look like? All right, so just kind of a quick pick. Y is equal to x squared minus 2x plus 8, and a quick zoom 6. Oh, okay. It doesn't come that far down, all right? Question? That's correct. And so what we want to do is make that connection between, well, what do we have there and what does this picture show us? Well, what this picture shows us is that there are no x-intercepts. Why is that? Because you can't take this square root. So because you cannot take the square root of negative 28, that means that this formula doesn't go and there are no x-intercepts. The second one, if we just change this to x squared plus 6x plus 7 and do a quick little look. This one has 2 x-intercepts. Okay, so there are 2 x-intercepts, and it connects with that same number. It's just that this number is 8. Now, is it possible to take the square root of 8? Yeah, right? In other words, yes, we can take the square root of 8, or we can at least simplify it. We know that it's going to be somewhere between 2 and 3. And what are you going to do with that number after you get it? Well, you're actually going to do this. You're going to do 2 things. You're going to add whatever that is, and you're going to subtract whatever that is, and that's why you get 2 different x-intercepts. And so when we look at this last one, there's an 8 underneath there. And since it's kind of the same as this, we can take the square root of 8, we can add it to 6 and divide by 2, and we'll get 1 answer. We can subtract it from 6 divided by 2 and get a second answer. So before I even show this picture, I'm going to predict that there will be 2 x-intercepts. And now if I go here and I change this to a minus 6, looky there. There are 2 x-intercepts. All right, and that gives us this picture here. Oh, come on. Okay, you go behind. There we go. All right. Question. Excellent question. So the question was, how can you tell if there's only going to be one x-intercept? Well, it still comes down to that number underneath there. And let me check the next slide. How can we tell? So how can we tell if there's going to be 0 or 1 or 2? Okay, and the word is, it's called the discriminant. It's called the discriminant. Now, you know what it means to discriminate? No? Well, see, now discriminate, right, means to distinguish between. We typically, especially in sort of today's society, we think that discriminate is a bad word. And it is if you're applying it to people. But it's an okay word if you're describing or if you're applying it to other things, right? For example, I don't know if any of you have cats. Cats, you know, there's a commercial for, I don't know which cat food it is, but it's for your discriminating cat. Because they can tell which food is good, supposedly, and which food is not good, right? That's what it means to discriminate. And so having the ability to discriminate is good when it applies to certain things, right? And if you can't discriminate between, for example, temperature, you might put yourself into a position where you could harm yourself, right? Some people, they don't feel. Like physically, the nerve endings are dead. They could put their hand on a hot stove and they wouldn't know a thing, right? Because their hand can't discriminate temperature. Meanwhile, their skin is burning because they've got their hand on a hot stove. Right? So it's good to discriminate. Same thing with sense of smell, right? It's good to discriminate between what's a pleasant smell and what's not a pleasant smell, because if you can't discriminate, sometimes you might come into the school and go, you know, nothing, you think nothing's wrong, but especially early in sort of fall, there's an inversion of temperature and you smell gas. There's a gas smell in school. And so if you can discriminate that sense, you go, wait a minute, there's something wrong, right? So in mathematics, this is where we're discriminating. And it's good to discriminate because all we want to be able to do is tell the difference between which quadratic functions will have x-intercepts and which ones won't. So the discriminant, where is it? Well, it's actually the only place in the quadratic formula where all three variables are found. Right? And it's in the radicand. Right? Underneath the square root piece is where you have all three variables. You've got the b, you got the a, you got the c. So that's what's called the discriminant. And so the discriminant basically it kind of has this formula, and it's b squared minus 4ac. For your IB papers, there's a letter that's used to represent this, and it's the Greek letter delta. It's just a triangle, right? So this is what's called the discriminant. D for delta, D for discriminant. So the discriminant is b squared minus 4ac, and it allows us to quickly tell how many roots there are. So, as long as our equation or our function is in that form that we can identify what A is, what B is, and what C is, we can tell. Now this one we already know, this one factored, right? So we know that this should come up with 2. So what's the discriminant? Well, b squared is going to be 6 squared minus 4 times a, which is 1, times c, which is 8. So this is 36 minus 32, which is 4. Can you take the square root of 4? Yes. And then what are you going to do with it? You're going to add it and divide by something to get one answer. You're going to subtract it and divide it to get another answer. And that's why, since this discriminant value is positive, there are 2 roots. Since the discriminant is positive, there are 2 roots. Right? Because when we get that 4, we're going to add, well, the square root, then we're going to add the value, we're going to subtract the value, and that gives us 2 different answers. Question? Means I'm finished. Sorry, yeah, it just means I'm finished. Okay, So that was the first one, which we knew factored. So, how can you tell and explain your reasoning? It factors, and here are the factors. That's how I know there are two. Here's the discriminant, b squared minus 4ac. B squared minus 4ac gives me a value of 4, and because the discriminant is positive, there will be 2 roots, and they're going to be different. Okay, what about this one? This one we also factored, and it gave us 1. So now here to answer your question is, how can we tell? Well, what we do is we look at the discriminant. B squared minus 4ac, so that's going to be 8 squared minus 4 times 1 times 16. 8 squared is 64, and 4 times 16 is 64, and when you subtract them, you get 0. What are you going to do with that 0? You're going to take the square root. 0. What are you going to do with that? Well, you're going to add it and divide by 2, or whatever. And you're going to subtract it and divide by the 2a. Well, if you're adding 0 or subtracting 0, you're getting the same answer, right? And that's why this one, since it equals 0, there is only 1 root. And we use some kind of different terms. There's 1 real root. Okay, there's only 1. And we saw this from this one. The only root is x is equal to -4. So that's kind of scenario number 2. And then scenario number 3, I think this is the other one we just did on the other page there, right? All we need to look at is the discriminant. We don't have to use the whole quadratic formula, right? B squared, so that's -2 squared minus 4 times 1 times 8. And that gives us 4 minus 32, which is -28. And because it's negative, there are no real roots. Oh, yep. There. Seven question. But it answers a specific question. What's the question? How many? It doesn't give you what they are. That's correct. Right? It doesn't give you what they are. But at least what it does is, if it's positive, then you know, oh, there are some roots. I better keep doing the rest of the work to find them. Absolutely. Yeah, absolutely. So to answer that kind of, what is this useful for? It's useful to know if we should really go about doing the rest of the work. Right? Now, do you have to use this? Well, only in the scenario where the A and C value are both positive and it doesn't appear to factor, then we need to kind of do one step further. And that's what the discriminant is useful for. Okay? Now, underneath here, I kind of added, or I changed one word. I added a word. The first time I said, well, since b squared minus 4ac is greater than 0, there are 2 roots. Well, technically speaking, because a quadratic has an exponent of 2, there are always 2 roots. The question is, what's the nature of those roots? Right? That was the title of our lesson. So when you have this discriminant that's positive, we say that there are 2 distinct real roots. And in this particular example, I think the roots are negative, well, I don't know what they are, -4 and -2, right? There are 2 distinct, different, in other words, x-intercepts. This one here has also 2 real roots, but these ones are equal. So you can either say that we've got 1 real root, or that we've got two equal real roots. It means the same thing. And then the last one, if there are no real roots, but we want to say that there are two, what do we call them? Close. Okay. Now, how many of you have real friends? You all do, right? If you don't have real friends, what do you call those friends that aren't real? Yeah, imaginary, right? I was going to say Facebook friends, but you call them imaginary friends. And in mathematics, if you have the discriminant that's negative, then what you have are what are called imaginary roots. It's like, oh, sure, Mr. Garkey, like you have imaginary friends too. Seriously, this is what they're called. They're called imaginary roots because there is well, let me just explain it this way. In Math 10C, you had a unit on number systems, right? Where you were refreshed, I hope, on the natural numbers, right? Numbers that you learned to count from when you're a child. And then beyond that, you learned about a new number system called the whole numbers, right? Which introduced this concept of zero. And then after the whole numbers, you learned, especially living in Edmonton, about integers, that you can have numbers that are negative. And then beyond that, when you get into, I don't know, grade school somewhere in there, you realize that you can have a piece of something. And so you learn this rational, fractions, rational numbers. And then after the rationals, you learn about these irrational numbers, right? Numbers that have decimals that do not repeat, but they do not stop. Like pi is a good rational number, irrational number, right? And all together, those make the real numbers. And so you're kind of like, oh, okay, sweet, I'm happy, I've got all the numbers I ever need. The answer is, nope, you don't have all the numbers you ever need, because there are more numbers than just the real numbers. And these imaginary numbers fall under a set of numbers called the complex numbers, which used to be part of high school math curriculum, but has gone away probably, I don't know, maybe even your parents may or may not have taken it, depending upon what they did, because your parents are probably relatively close to my age. So they may or may not have taken or studied what are called complex numbers. But if you're bored over the weekend, Google complex numbers, have a look. The basic idea is it's founded off of what value, when you square it, gives you a -1, right? Because that's the issue here. The issue here is we can't take the square root of a negative number. So what mathematicians did is they said, why should that stop us? Let's basically invent a number system where we can, and then let's keep on going. And so that's basically what they did. So anyway, we say in terms of the nature of the roots, you can either say, and we typically say, that there are no real roots. Some people will say, well, there are two roots, but they're imaginary. Right? And so either way is how you can describe them. Right? So that describes what we call the nature of the roots. There are always two of them, but what are they? Two distinct real roots, two equal real roots, or really one root, and then two imaginary roots, or no real roots. So this section here, we've got just sort of 6 examples, A, B, C, D, C, D. Oh, and then we got a little bit more. So what time are we sitting at? 3 o'clock? Let's see what's interesting here. Oh, well, let's go through, and first of all, we don't always have to use the discriminant. So can we look at these and say, before we do anything, yep, we've got 1 or 2 for sure. Are there any that we can quickly look at to look over these? I don't know if I can make them a bit bigger, but not a whole lot bigger. Are there any that we can kind of look at right away and say, yeah, 2 roots? Okay, so hand up which one? Hands up which one? D? Which D? Which D? There's 2 Ds. So 3x squared plus minus 6x plus 3. How do you know for sure? Okay, so this one you could factor, right? Easy enough, relatively. And you've got a 3 out here, so right away we can tell that this will have 1. But we can use the discriminant. Shayla? B? How many? How do you know? What's opposite? Right? Don't just say they're opposite, because I'll say what's opposite, right? A and C are opposite, so right away we know that they're going to be 2, and they must be distinct. Okay? Florian? The other D, okay? Right, and once we put them on the same side, A and C are opposites, so right away, yep, they're going to be 2 distinct. Okay, anything else? Celeste, A, what? How do you know? Okay, factors, right? So if you can factor it, it's a nice perfect square trinomial. And so it factors into square root kind of of each, which means there's only going to be 1 real root or 2 equal real roots, right? There's 2 of them. You can see I've got 2 factors. It says that they're identical. Okay, so that really only leaves us down to 3 of them. Sorry, 3 of them. 2 of them. So we got this one, and we got this one. All right, and we can't really tell. So try the discriminant on those 2, and then let's see. Okay, so we only have 2 to work with, and you can work exactly with what we have. I'm not multiplying, and I'm not getting rid of the negative. I'm just working exactly what I have. So b squared minus 4ac, 7 squared minus 4 times negative 2 times negative 9. And so usually I just kind of walk through and say, well, am I adding or subtracting? So all those negatives there leaves a negative for subtracting, and then 4 times usually something is easy to do, and then something else is usually not so hard. And then 49 minus 72, and right away I can see it's going to be negative. Okay, whether you get the actual number or not, well, you should display what that number is. And because this is negative, now we know that there are no real roots to this particular equation. In other words, this graph, we could predict what it looks like. Right? It opens down, and then the vertex is down below that x-axis. And our last one here, so we first of all need to pull everything to one side. I'm going to pull it all to the left-hand side because that's where the x squared term is currently positive. So subtract 12x from both sides, add 2 to both sides, and now b squared minus 4ac becomes negative 12 squared minus 4 times 9 times 2. And this is 144 minus, that's 72 again. And so this is 72. The discriminant is 72. Therefore, I don't know what the roots will be, but I know that there will be 2 distinct real roots. Okay. Good. All right. So this discriminant, this little expression underneath the root sign, so it's our radicand, right? Very powerful. All we have to do is evaluate. And then based on what it is, greater than, equal to, or less than 0, tells us what the nature of the roots are. It tells us how many x-intercepts there will be, tells us how many roots there will be to any equation. That's kind of the basic moving forward kind of process. Second kind of process or question that typically gets asked is, if you consider this equation that's not fully complete. And I think this is our, yeah, I think I looked, this is our last slide. If we have an equation that's not complete, 5x squared minus 10x plus something, for what value or values of k will this equation have, and then you can pick basically what scenario you want. So the first example that we'll do is this example that says, for what value of k will this equation have no real roots? So I put it in nice red there. This is the condition that we're looking for. We're looking for no real roots. Okay, so in other words, there are a lot of different values that we could put there at the end. Depending upon what values we put there, sometimes we'll get 2 real roots. Sometimes we might get 1 real root, right? Or 2 equal real roots. And for certain values, we'll get no roots. For example, can you think of a numerical value of k that would give you 2 different roots? Right, okay, good. AC, that kind of idea. So if that k value is anything negative, you've got a positive 5 as your a value, anything negative there will definitely produce 2 different real roots. Okay, so that one we didn't even have to use the discriminant for, but now what about no real roots? Okay, so at what point on the sort of positive side does this sort of kick in? Well, all we do is we use the discriminant, right? So to have no real roots means that our b squared minus 4ac has to be, to have no real roots, has to be negative, right? Has to be less than 0 because we can't take the square root of that negative number. Okay, so let's substitute those in there. So what's b? Well, b is negative 10 minus 4 times a is 5 times c is k, and we want that to be less than or equal to 0. So what we have here now is an inequality that just has the letter k. So we want to solve this inequality. Okay, so negative 10 squared, 100. Negative 4 times 5 times k is minus 20k, and that's less than 0. Now solve it for k. I'm going to give you 2 minutes, and then we'll see if we got it the right way. Okay. Do you remember how to solve inequalities? Not if there's not an equal sign. If there's an equal sign, then there's one answer. If there's an inequality sign, there's an interval of answers. So see if you can get the right interval. Sorry? Yes, we're looking for this place where it will have no real roots. One minute left. And I haven't been counting, so I might be off. Okay, anybody need more time? Okay, then I'll stop. All right, so answer K, 5. So far, so good. K less than 5? K greater than 5? K equal to 5? Okay, so, or a mix. So let's show of hands. K equals 5. Okay. K greater than 5. Okay. K less than 5. All right. I'm not sure if we got all the hands. So, when you're doing this problem, how many of you at this point subtracted 100? Okay. How many of you added 20K? Okay. Well, what did you do? You didn't either subtract. Okay. How many of you divided by 20? How many of you divided by negative 20? Okay, because now I'm lost, because if you didn't do one of those 4 steps, I'm not sure what you did.
What if you just like looked at K and just said, oh, it needs to be this? I don't think anybody did any math.
Okay, so on your IB paper, 2 marks out of 5 because you have to show work. Sorry. So what do you do? So this is why I'm asking. There are some potential things that you could do. Shayla, question or comment? Okay, can you do that? Can you look at this and can you subtract 100 from each side? Absolutely. You can do it if it's an equation. You can do it if it's an inequality. Absolutely. Right? That's one of those mathematical things. If you subtract 100 from each side, your next line will look like this. I hope. On the left-hand side, you should have minus 20K. Oops, I shouldn't do that yet. On the right-hand side, you're going to have negative 100. What sign will I have there? Same sign, right? The same sign. Subtracting doesn't change. Does adding change? No. Okay. Well, next step. By negative 20. Okay, so when you divide by negative 20, you get K and 5. What about the sign? Say it again. That's the key, right? This is the key. The key is if you divide or multiply, if you multiply or divide by a negative, switch direction of the sign. So in other words, now K is greater than 5. Okay. The logic basically dictates, I'm going to go back to what Jordan said, to start off with, if K is negative, I'm going to be having 2. So I can't use any values of K that are negative. So in terms of my inequality, when I'm comparing it to 5, it can't just be K less than 5, because then I'm going to get values down there that are negative. So that's one logical reason why it's probably on the right-hand side of 5. Okay. Here's the other thing that you could do, and this is why I asked, how many of you subtracted 100? See? And if you do, when you divide by the negative, you got to switch the signs. What if you didn't subtract 100? What if you added 20? Well, if you'd add 20, it would look like this. The 100 would be on the left. If you add 20K to both sides, you're going to have 20K on the right-hand side. And does adding change the sign? No. So it's going to still point to the left. And now the last step would be divide by positive 20. And if you divide by positive 20, does that change the sign? And the answer is no. And so it would point this way. Now the question is, are these two things saying the same thing? And the answer is yes. Right? Here, 5 is less than K. Here, K is greater than 5. It says the same thing. Right? So that's why be careful when you're working with the inequality if you're dividing by a negative. Right? And that's kind of hopefully grade 10 for sure, I think. We did some, maybe even in grade 9. So that's our solution to this problem. For what value or values of K? Any value where K is greater than 5. Guess what happens if K is equal to 5? Yeah, you get one real root, right? Because if it's equal, that would be equaling the 0. And guess what happens if it's anything less than 5? 2, right? You only really have to do the work once to kind of establish all of the different possibilities. Okay? Now, what else do we got here? So we kind of have two more that are sort of similar, except sort of different. Now, the next one says, consider this equation 4x squared plus kx plus 9. And it says, for what value or values of k does this equation have one real root? And then consider this, for what value or values of k does the equation have two distinct real roots? And so, since it's almost 20 after, we're kind of not short on time, but we're almost done here. What we'll do is I'll leave these two for you, and then we'll come back tomorrow. We'll finish these two off, and then that way tomorrow being Thursday, you have basically time to work on this homework. You can also work on review. Okay, you should have a review. Friday, what we will be doing is we just have our quiz on Friday, and it's only a one-page quiz. There's only like 5 questions, I think, 5 or 6. And then you can, once you finish that, you can keep working on the review. Monday is our day to go over any review questions. Tuesday, down there, is the day of our test. Okay, so I want you to work on these two. I'm going to stop the recording. I will post this recording, and then tomorrow when we finish the last however many minutes, I'll post that recording as well, so that kind of everything is there. All right? I will post what we have in terms of these written notes tonight, and then I'll also repost it once we finish those last 2 examples. Okay? And if you're wanting to kind of get a start on the homework, because most of the homework relates to just the discriminant value, but there are probably a couple questions like this, whatever it says on the outline. So on the outline it says, nature of the roots there somewhere. Nature of the roots, discriminant, selecting a strategy, page 254, the questions that are there. Okay. Yeah. Okay, so I'll go back. I'll leave these 2 up in case, so you need to write them down. Make sure you've got the k in the right place. And then make sure you're addressing what the scenario is. How many roots are we looking for? Okay, and then we'll pick it up from there tomorrow.